Hello everyone, welcome to next training session tutorial in the series of Java 8 and Selenium WebDriver. This is Java 8 part 5 and let's see what we are going to have a look at on this session. We would see more stream operations. We would see we have method implementation on interfaces in Java in forms of static and default methods. We have never seen a method implementation on an interface, and this is, when I saw this first time few months ago, I was like, what the heck. We will have a look at integer stream here and the range method. We would see a couple of stream operations like sum, sort, and average. We would also see how we can add double numbers. We would see reading content of a file, how we can collect content to a map. We had seen list, so this time we are going to see collectors.toMap method, and in the end we would find out what's with the WebDriver examples. So let's get started. So here I have set up a new class called stream miscellaneous, stream miss, with the new set of examples. I'm going to commit this on my GitHub account, which I would link on the description of this ticket. And if you're new to Selenium and Java, then please do not start here. Please start on my Selenium and Java training sessions, something I'm also going to link on the description of this video. So let's get started with integer stream. So what is integer stream? Well, its name is quite obvious, and it is a stream of integers, hence it is called integer stream, which is an interface. So I spoke of static and default methods on an interface, and this interface has got static method for us, which is known as range here. So this API takes two arguments in terms of integers. First argument is inclusive, second is exclusive. And the thing to note here is that we are talking about an interface here, but it has got a method, a static method, and we have implementation. So we did not have method implementation on interfaces till before Java 8, and this is a new feature on Java 8. And we can have two sorts of implementation on an interface. We can have static methods. Static methods cannot be overridden, and we can have default method. Let me see if we have a default implementation here. Yeah, so there's a default add method here too, which is having implementation. So let's get back to our exercise. What we are doing in this exercise is we are calling the range method for numbers between 1 to 10. We saw that 1 is inclusive, which is first argument, and 10 is exclusive, which is the second argument. And then what we do, we use for each, we invoke for each API, and then we print all of the numbers using system.out.println, and I'm using the method reference syntax here, which we have seen many a times in past. So let's print this, and we should see 1 to 9 being printed. So I'm going to run this program, and you see here we have 1, 2, 3, 4, 5 till 9 being printed. Pretty easy. Let's see the next set of statements. Let me comment this and bring the next set of statements to life. In the next set of statement also we have integer stream. I have named it as another integer stream with the range 1 to 10, but what we are doing here is we are calling the sum method to sum all of these numbers. So if I run this, we would have numbers from 1 to 9 being summed, this which is 1 plus 2 plus 3 plus 4 plus 5 till 9. So if I run this, we would get 45. Yeah, let's see. Yeah, we get 45 here. I was able to sum it a bit fast because there's a catch here that if you want to sum numbers, say for example 1 to 10 or 1 to any digit, what you can do is you can take the number before the last number. For example, 9 is the last number here, and then you can multiply 9 with the last number, which is 10. So 9 multiplied by 10 divided by 2, it gives you 45. Very easy to calculate it without calculator. Now let's see next set of statement, which is this is quite interesting. Now what we are going to do is we are going to sum the doubles here, and this is quite different in terms of syntax than what we saw here, adding the integer numbers. So let's see what we have. So we declared a stream of double here, and how we have initialized this, using auth API on the stream. Now, if you see, the auth is another static method on stream interface, and we saw that interfaces from Java 8 are allowed to have implementation. So this is the implementation of auth, which is no rocket science. What it does is it takes the values and it initializes or creates a stream and returns it. That's all. So we created a stream of double, which is having values 1.1.0, 3.5 till 4.3. And now we have to add these stream, as in the double values in the stream. What we can do here is we can use an operation called reduce here, which takes this method is overloaded, and the implementation of the reduce which we are invoking here takes identity, which is the starting value, and a binary operator. So identity is quite easy to understand. This is a double value and our starting point is 0.0 here. But let's see what is binary operator. So I would jump into the definition of reduce. We have binary operator here. What is binary operator? Well, binary operator is another functional interface, and this does not have any abstract method. So that's quite surprising. So where is the abstract method coming from? Because since we are applying Lambda on it, it must have an abstract method. If we look closely, you see that it extends by function, which is another functional interface, and this functional interface has an apply method. So this apply method takes 2 arguments, and then it applies the given function on these arguments. So let me go back to binary operator, and since it extends the by function, which has an abstract method, and binary operator does not implement this is the reason why binary operator itself is an interface. The very basics of Java: if if a class extends an interface and class does not implement the methods of the interface, then the class itself is not a complete class. So here our binary operator is also an interface. Now, since binary operator is having only one abstract method, apply from the by function, which is not implemented, hence binary operator class becomes a functional interface. Let's go back to the operation which we are carrying out, reduce. So we have identity here, and then binary operator, which we saw takes 2 arguments on the apply method. And from the previous series of videos and tutorials, we have learned that arguments in Lambda go on the right hand side. Arguments on the Lambda go on left hand side, and implementation go on the right hand side. So these are the arguments which are on the left hand side, and the implementation is on the right hand side. We want to sum the numbers, so we are just adding them here. Now, if you look closely here, what we have with 0.0 is the starting value, and then we have D1, which is the first value, a running total, and then we have D2, which is a new element which is being passed. So the first time when the control comes here and this expression is evaluated, then D1 is 1.0, which is D2 is the running total. So the first time, well, there is no running total, so first time we have 1.0 coming in here, which is added to 0.0. Summation is 1.0. Then 3.5 comes in as the new element on D2. At that point of time, the running total is 1.0, then 3.5 is added, and so on and so forth. Now, if you look at the definition, API definition of reduce, you will find out that this is not something very different than what sum does. Is actually sum, min, max, average, string concatenation. They are all special cases of reduction according to the API. So sum could also be written as in the same format: dot reduce, 0 initial value, a the running total, and b the value which comes in to be added. So we could also do sum using this syntax, or we can just call the sum API, which we saw above. So after we have added all of the double values, we can print them. Let me print this. Let me run this, and it's going to add all of the values from 1.0 to 4.3, and the outcome is 20.6, and I believe that's the right outcome. Now let's see what we have on next set of statement. And next set of statement, what we are doing is, okay, so we are again instantiating a stream of strings using a static method which we saw before of. So what we have here, our string stream is StringStream. That's the name of the variable here, and we have initialized it with different names like Marius, Oleg, Svetlana, Thierry, Alex, Balint, and Tarun. And now what we can do on this string stream is we can sort it. So all of these values will be sorted in alphabetical order, and then we are collecting them to a list. We had seen collect many a times in past, so they should not be difficult to understand. And then for each of the element in the list, we are printing the values. So if I run this, we would have all of these elements being sorted and then printed. So let me run this. If you look here, we have Alex printed first, and Balint, Marius, A, B, M, O, S, T, T, A, and T, H. So they are all sorted in alphabetical order and then printed. Yeah, can you think of where we can use this on WebDriver, sorting operation and some sort of assertion? Actually, what I could think of is, we come across lots of tables on web applications which have sorting operations. And what we can do is we can collect all of the elements from one column uh, on, on a collection, for example, and then we can sort this using the sort API on the stream and store the results on an object. And then what we can do is we can sort the columns again on web application, and then we have the sorted values. Then we can again collect them and compare with the sorting which we had done using the stream. And if these two are equal, then sorting is working. Simple, isn't it? Or not? Okay, let me try to explain again. So where we can use sorting operation is, for example, we have a table on web application, and table has different columns, and we can apply sorting on these columns. So what we do, we first extract the column values and then store them on a stream and then sort them and then create a list out of it. So we get the sorted values from stream operation. Then what we do on the front end, we perform the sort on a column, and then we collect these values again. Now the values which we had sorted using the stream and the values which we got after performing sorting manually on the web application, we can compare these two and find out whether sorting is same or not. If not, then, well, there's something wrong. Now let's see the next set of statements. What is happening here? Okay, so we are again having a stream of a string, and what we are going to do here is we would do sorting and then we would apply a filter on it. So a stream is going to contain few names here, and then we are sorting it. What filter we are applying? We are filtering the names which have letter I, and we have seen from past tutorials that filter takes a predicate, which is another functional interface, and it has a test method which takes one argument. So what it does is it evaluates the predicate on this arguments, and then it returns us whether whether the result is true or false. So if I go back, this is our predicate here, since it takes one argument, and we know argument goes on the left hand side, so S is on the left hand side of the arrow and the implementation is on the right hand side. What we do after this is we find the first element and then we print this element. But what I have done here is I am using or else, which we had seen in the previous session from optional, because find first gives us an optional which may be empty, and in case this is empty, then we would have no string matching filter was found printed. But we know here that we have I in at least two names, and when sorting happens, then M comes before T. Yeah, M comes before T, so Marius should be printed. Let's run it. Yeah, if I change it to something which is not available, for example IWE, then we would have default value printed. Yes, you see the default value, no string matching filter was found is printed. Okay, let me bring it back to how it was. Let us see next set of statements. Next set of statements, what we are doing here is we are okay, what we are doing here is we are again filtering names on letter XYZ, but we know that XYZ is not available anywhere. So when we find first, optional will be empty, and if present would, execute this statement only if there is some value. Let me comment out this part first. And if I run this, we would have nothing printed because none of the element of the string stream satisfy the condition of having XYZ. So if I run this, the outcome is, well, nothing. That's all. So nothing is printed. So let me move on to the next one, which is we are doing some mapping here. So what we do here is we create a stream of array elements here, which is integer array, and then we triple those elements, and then we find average of those. Okay, so how we are creating a stream here is we are creating a stream from arrays class. You may have used array class many times in past with arrays.aslist, and with the Java 8 we have something called stream API added to arrays class here. So this is stream API, which takes integer array, and we are using it here to create integer stream. And what are our integer values? We have 1, 2, 3, and 4 there. And then how do we convert these elements, as in how do we multiply 3 to each of these elements? Well, we saw this in past. Whenever we want to transform elements of a stream to something else, then we use map. So we are using map here, and here map takes integer unary operator. This is not something which we have seen in past, so let's have a look at this. Integer unary operator is another functional interface, and it has apply as int method on it. So it takes one argument, and then we can apply whichever operation we want on this argument. So let's go back. So the operation which we are applying here is n multiplied by 3. This code is not formatted. Let me format it to code. This is better. Now it's clearly visible. So we are applying the operation of multiplying the numbers by 3, and then there is a method on integer stream called average to find out average, which gives us a double. Well, it could be optional. Why would it be optional? Let's see the API. Okay, so it may be a case that stream is empty, and if stream is empty, then well, we will not get any double value. And then what I'm doing is I'm doing get as double. This is a specific statement, get as double, is sort of highlighted here because I'm not really performing a check here is present, and this is something which I should do first. Anyways, I know here stream is not empty, so I would have average being carried out against these numbers. So let me run this, and then we would have average printed. So these all numbers are multiplied by 3, and then we have average of all of this taken, and this would be 7.5. Let's see what we have next. File operation. This is quite interesting. Now what we would do is we would read, oops, not this. Yeah, this is right. I have to bring back some of the imports. Yes, they are back. I use option enter for this on Mac. Not sure of Windows syntax here. And then what we do here is, so we are reading a file here, and how do we do that? So with Java 7 we had an API called file, which we are using here. This was introduced in 1.7, and we are studying it in 2021. Better late than never. So using this class, we can read lines from a file, and we have to give its path. Now, if you see the API here, what it takes is it takes, yes, if you see API, it takes path. What we have passed here is path. So path itself is another interface, and we have a couple of util classes for this from paths. So we are using paths here, and one of the API on paths is get, which gets us path, and this is how we are able to use paths.get to get the path, which is passed to lines API. And what is the argument of get? Well, we have to pass the file path, and my file path is sampledata.txt. So let's see this file. So I have the file under com.selenium.toast blah blah blah. It's a quite big path, but it's okay. And what is the content of sampledata.txt? I have a couple of string values here: selenium test, jmeter, qtp, and so on. So what we are doing here is we are reading all of the lines of sampledata.txt, and each line would be stored in this stream called data stream. And now on this StringStream, we can apply whichever operation we want. What I have done here is I have applied filter, which takes a predicate. So I have argument on left hand side and the test condition on right hand side. My test condition is get me those rows which have value test, and once I get them, then I print it. In the end, what I should do, or what we should do, is we should always close the data stream. Otherwise, this is going to have some memory leaks. And then my question to you is, can you find out where we can use this in Selenium? Let's first run it and see how this goes. Let me comment this part. So we have less print statements. So if I print this, we should have Selenium test and jmeter test printed, because these two have test word test in it, and you can see it here. Selenium test and jmeter test are printed, and rest are ignored because they do not contain word test. Now, can you think of it where we can use this in Selenium? Well, it's quite easy. Many a times we end up dealing with files or data sets which are on external files with Selenium, and if we want to exercise only specific data sets because of some conditions, then we can use files.lines to get the stream over the file and then filter it on whichever condition we want. Simple. Let's see next operation. So next operation is on a different data files, which is BigData.txt. Everyone talks about big data, so I thought I would also create a file called big data. And what we want to do here is we want to find out who has got salary more than $70,000. So let's see what BigData.txt file has. So BigData.txt file has a couple of rows with employee ID, employee name, salary, and the country. And we have 3 entries here which have value of salary more than $70,000. So the condition here is we want to find out all of the rows where salary is more than $70,000. And now if we think of this, how we are going to apply this is, well, you may have already guessed that we are going to use the files.line we saw earlier to get a stream with string values for each of this line. But if we want to filter it on the condition of only those lines which contain $70,000, then we have to somehow get access to the third column here, and we know that we can split a string, and our operation split is going to focus on comma here because these all are comma separated values. So if we split the string, then we get an array, and on this array we would have salary at 0th, 1st, 2nd as second position. So if we somehow get access to the second position element on the array, then we can compare whether it is greater than $70,000 or not. Let's see how we do that. So first we create a StringStream from the data set which we have, BigData.txt, and then what we know is that we have to somehow convert each of this StringStream row into an array. And how we do that? I said this before, we are going to split. And when we want to transform the values of a stream to something else, what we use? Well, we use map. So I'm using map here. So we have map here with implementation of splitting the stream over comma. So once we do that, then what we end up with, let me bring control here. We end up with another stream which contains a string array, which is something you see here, a stream string array, which is returned by this map because we are doing a split operation, and a split gives us a string array. Now we have got, a stream which contains a string array, and now we can get to the specific salary element here. Once we can do that, then, well, we know how we can do comparison or filtering. Well, the name is filtering, so the next operation is filtering here. And then how do we filter? We filter using a predicate. We have seen it time and again. So what we have to do is we have to get D2, which is the salary element. I have trimmed it because there are some spaces, and it should be greater than 70,000. But well, 70,000 is a number, and our stream we saw here is going to contain a string array. So we have to first convert this into integer, and I have used, well, integer.parseInt. So this is going to pass whichever salary we get here. So this is passed here, and then this is compared whether it is greater than 70,000 or not. If it is greater than 70,000, then, well, we just want to fetch these values. So what I'm doing here is I'm printing them using for each, which takes consumer, which has accept method. We have seen for each many a times. It takes one argument, so it's going to perform the operation on the given argument, and our operation here is system.out.println. So we are just printing the values of stream array here. And how many values we have? We have total 4 values: employee ID, name, salary, and the country. And in the end, we are closing the stream. Let's see this once again if it was confusing. Our problem statement is that we want to find out all of the streams or all of the data sets on BigData.txt file where salary is greater than 70,000. So somehow what we have to do is we have to reach this element, and we know that we can easily create a stream of a string. And after creating a stream of a string, what we have to do is we have to reach the third element here. So to be able to do that, what we did, we first converted this into a stream of a string array by applying the split method on map, and then we filtered out all of the values where in third entry, which is salary, is greater than 70,000, and then we just applied for each on it to print all of these values. So let me run it. So you see we have all of the employees having salary more than $70,000 is printed here. May appear a bit complicated at first, but if you try to do it yourself, you would master it, I'm very sure. Let us see next operation, which is not very different than what we saw earlier, but let me bring the imports. This is causing trouble. Yeah, I have got all of the imports here, but what we would do here is instead of just printing, we will collect it in another map so that we can exercise it somewhere down the line on the WebDriver. So first line remains the same. We read the StringStream using files.line. Here the file is the same, BigData.txt, which we saw before. And then we apply map on this. We saw map before also. We are splitting string on comma here. And then we apply filter. We saw filter before too. And here we are filtering it on employee set having salary more than 70,000. And then something changes here. What we have to do is we have to collect this in a map. So far we were using collect, and on the collect we were using collectors.toList, but here we have collectors.toMap. As its name indicates, toMap is to collect the values on a map. But what values do we collect on the map here? Because if I could show you the last run, yes. On the map, well, from the definition of map, we know that it's going to contain key value pair. So we have to somehow guide the map to identify what is key and what are the values. So what I have done here is I have considered employee ID as key, which would be unique, and rest of the values as values on a map. So what I do here is I'm creating a map which contains, well, what? It contains a string as key and then list of string elements as values. So if you see the syntax of collectors.toMap here, it takes two functions, and we know from previous sessions that function is, well, functional interface, which has apply method, and it's going to apply whichever function we declare on the argument which we pass to it. So if I go back and see this definition here, to map, so I have two functions here which are separated by a comma. First function is here, key, so here in where I specify that this is going to be the key to the map, and the second function is value, arrow, and the values. And how I have gotten these values or the list of string values, well, I'm using something called arrays.aslist, and the values it is going to contain are value 1, 2, and 3, which are this 1, 2, and 3. So arrays.aslist we have seen in Java tutorials as well, that we can use this to create list of a string, and this is what is happening here with the values of map. Let's focus on this once again. Let me format this. Yep. Let's try to understand this once again. So we would want to filter all of the employees whose salary is greater than 70,000, same as before, but now we want to collect this on a map. And how we do that is we again use the collect API, but instead of collectors.toList, we are using collectors.toMap, which takes two functions, and these two functions are what we want to do. What we want to do here, we want to have keys and values, wherein key is the employee ID, so it's going to be the first value in the stream of a string array which we get from filter, and the second value is the values of the map, which is nothing but arrays.aslist, because we want to convert all of these values to list of a string. And then we have specified values as values 1, 2, and 3, and this is collected in this big data map. At last, what I'm doing is I'm applying for each on big data map, and I'm just printing the values. For each takes consumers, so arguments are going on the left hand side, which are k and v here. You can name it whatever you want. And on the right hand side, we have implementation, which is just printing the key and values here. Similar way, this key and values, they are just the names. You can name it whatever you want. For example, I have named it key and value because it makes it easier to understand that I'm storing key here and value there. You can name it whatever you want, WTY or DFT, doesn't make any difference, but well, code should be comprehensible, and this is not going to make it comprehensible if I write names like WTY. So I would name it back to key and values. So easy. Moreover, if you have a look at this is still quite not so comprehensible to understand. Even this line is also not so comprehensible to understand. What I would also do is I would create a method called salary greater than 70,000, and then I will call that method here. So it makes it really easy that filtering is happening on salary greater than 70,000. In the similar way, I'll say map from employee record, and then I would pass on whole of this syntax to another method, and I will say here collect map of employee record. So we really just have a look at the statements and figure out what is going on without getting into the nitty-gritty of what lies behind those methods until unless we need it. I have not done in this exercise. Let's consider this as an exercise for you to carry out. What we are left with is, let's run this program and let's print the value of big data new. So you see the map values are being printed here. Key is the key of first element and of first row, and the values are of first row. Then second row, values from the second row, then third row, and the values from the third row. Simple, isn't it? Now, once you have got the big data map here, you can use this data set however you want in a form to fill in the values using SeleniumWebDriver, or you could be collecting these values from a page using WebDriver, and then you could uh, do some operations on these elements on the map. So this was the last set of exercise on this session. What next? WebDriver examples. Actually, I have not created any WebDriver example this time because you know that once you get hold of these controls, you can easily find out what you can carry out with these elements on a page, or how you can use WebDriver around these, these set of statements. So it should be quite easy for you to derive WebDriver operations out of these statements. Yeah, so this is all for this session. And if you found this session useful, educational, then please hit the like button. And as Jim Carrey says, I wish you good afternoon, good evening, and good night. Have a nice day. Bye bye.